So we're going to walk through two different mechanisms. It's the formation of hydrates in both acidic and basic conditions. Keep in mind when you do reactions of carbonyls in acidic conditions, the first step is typically protonating the carbonyl to make it more electrophilic. In basic conditions, you typically have a strong enough nucleophile that you do not need to protonate first. So let's walk through this. For this reaction, we're going to um, basically do an addition reaction to this carbonyl, this aldehyde. We're adding water, and therefore we're going to form a hydrate. This oxygen is going to be one of these, and the oxygen from water will be the other eventually. So the first step, as I mentioned, is we're going to protonate our carbonyl with our acid. And it's going to look something like this. And I'm going to put the lone pairs in there. And we'll protonate that carbonyl. The lone pair from the oxygen of the carbonyl is going to add to one of the hydrogens in our acid. And then that hydrogen is going to break free from the oxygen. And our result would be this structure right here. Now, in the next step, we're going to have our nucleophilic attack. Because we are in aqueous conditions, we have water here, and I'm going to draw it below the arrows so it's easier for me to do the curved arrows. But the water now is going to add to our electrophilic carbonyl. When it adds to the carbon, I need to remove the carbonyl bond so carbon will not exceed 4 bonds, putting a lone pair up on the oxygen. Keep in mind there's already a lone pair up there, so our product will have 2 lone pairs, and therefore it will not have that positive charge anymore. This oxygen is using its electrons to form a bond, so it will have a positive charge. And so if I look at the product of that step, we can see that we have our water added to the carbonyl, the positive charge on the oxygen we just added. And then the last step would be deprotonation. We're going to remove one of these excess hydrogens, and water is going to do that. So we have our water molecule still present in solution. They're going to use one of those lone pairs to deprotonate that hydrogen, and we're left with our hydrate. So again, in acidic conditions, when you're dealing with carbonyls, typically you do a proton transfer to protonate the carbonyl to make it a little bit more electrophilic. And then we do our nucleophilic attack of our nucleophile, in this case, water. And to finish things up, we need to get back to a neutral compound. So we're going to do another proton transfer to remove the excess hydrogen. Now, if we were to do it in basic conditions, our nucleophile is strong enough that we do not need to activate our carbonyl. Our nucleophile will just directly add to the carbonyl and push the electrons up to the oxygen to get a negative charge. And what we see is this structure right here. And then all we need to do to get to our final product is put a hydrogen on that oxygen. And we're in aqueous conditions, so water, which is either an acid or a base, depending on the conditions, is going to act as an acid in this scenario and donate a hydrogen to our oxygen, giving us our hydrate product. So it's one fewer step than acidic conditions because we don't need to activate our carbonyl. Keep in mind that in acidic conditions, I didn't see any negative charges. In acidic conditions, you typically don't see that because you're always going to have things protonated or overprotonated to where you have a positive charge. Where in basic conditions, you tend to see negative charges, but not positive charges, because having an additional oxygen on or hydrogen on an oxygen would be too acidic for these conditions. Whereas in acidic conditions, deprotonating all the way would be too basic for these conditions. So they're just little things to kind of identify. But again, if I were to label the steps over here, we would have nucleophilic attack followed by my proton transfer. So that is the reaction mechanisms for a hydrate. It is a good place to start when you're learning about mechanisms of carbonyls, because as you move into your acetals, your esterifications, and so forth, a lot of these key concepts apply, but you're doing more additional sort of proton transfer steps to get leaving groups to go away and whatnot. So I will post more videos where I do reactions of other carbonyls in both acidic and basic conditions, but these two were the kind of starting point of hydrate formation. Very few steps, just getting us familiar with the mechanisms.